Hello everyone, welcome to Pepcoding. Today we are going to solve a question named ring rotate. So let's go on the board, discuss the question first. After that we will look for the solution. So we are given a 2D matrix here. So let's draw a 2D matrix first. 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, and 5 6. Just suppose this is the given 2D matrix we have. Okay, now let me tell you what is the ring that we have to rotate. Okay, so this is the first ring. Okay, this is the second ring that we have, and this is the last one. So if someone says we have to rotate the second ring, so it means we have to rotate this ring. If someone says we have to rotate the first ring, it means we have to rotate this ring. This ring is shell number 1, this ring is shell number 2. Someone says shell number 3, then they're talking about this one. Okay, so we are very familiar with rotation in 1D array, but not in 2D array. In 1D array, what was happening? If we are given a array, just suppose 1, 2, 3, and 4. If we have to rotate this array by 2, so what was happening there? We just divide this array from 2 digits from the last. And what was happening? These 2 digits come at the front and these 3 digits go at the last. So the answer was 4, 5, 1, 2, 3. This was the result if we have to rotate this given array by 2. Okay, but in 2D matrix, what is going to happen? Let me tell you. If we have to rotate the second shell by 1, so what we have to do? We have to rotate it by anti-clockwise direction by 1. So 22 will be 23, 32 will be 22, 42 will be 32, 43 will be 42, 44 will be 43, 45 will be 44, 35 will be 45, 25 will be 35, 24 will be 35, 23 will be 24. So this will be the resultant output that we need. Okay, so it is pretty simple. Let me tell you the approach to solve this question. Okay, so here we have 3 steps to solve this question. We are familiar with rotating in 1D array. So what we'll do, we will fill this shell in an 1D array. Then it is pretty easy. We will rotate that 1D array. After that, what we have to do? We have to fill back again this shell with that rotated 1D array. Okay, so first thing what we are going to do, fill our 1D array. Okay, after that what we will do, we will rotate that 1D array. So it is rotated. Now what we have to do, we just have to push back again in this given cell. So fill shell from 1D array. Okay, these are the 3 steps that we need to take care, and our question is solved. Okay, and we are familiar with this one, so this will be easy for us. What we need to take care is filling 1D array, and after that filling back shell from 1D array. This is also easy. We have done a similar question, that is spiral display. We will take help from that question. Okay, so let's go on the editor and write some code. So we are here. So first of all, we need input. So for that, what we are going to do, we are going to take input of n as a number of row. Then we have to take the input of m, which will represent the number of columns. Okay. Now we have number of rows and number of columns. Not what we need. We need to get the array, that value e1 1, e1 2, e2 1, e2 2. Okay, for that we need an array. We got an array. After that, for I in range n, we have to define one more array, that linear, which we will add it in the array. So that is also here. And now what we are going to do, we are going to define one more chain range of n. Okay, this is done. Now we will simply store our value first in a. So a dot append we have the value here. Now coming out of the loop, what we are going to do, we are going to append the a inside. Okay, this part is done. Now let's move forward. We have the input. Now we have to get the value of s and r, the number of shell, and how, by which value we have to rotate. So s is equal to int input. Now r. Okay, we have that also. Now we have divided the question in three parts. First was fill 1D array. Okay, let's go. We have to define 1D array first. This is the 1D array that we have. Now we have to fill it. Fill 1D array. Inside this we will pass our array that we have here r and the number of shell. This is done. This will give us the 1D array filled with that data of that shell. Now what we have to do, we have to rotate that 1D array. Okay, so rotate that 1D array by value r. This is also done. Now what we have to do, now again we have to fill back that 1D array. Okay, so fill back. We will send here our array and the 1D array that we have rotated and the number of shell. Okay, then after that we are left with only one step, displaying our result. Okay, this is also done. Now we have to write the function that we have called here. So let's go. First of all, we need to get this part, this 1D array. So let's go outside and write some code. Define, we have to fill 1D. Okay, inside this we have an array and the number of shell. This is done. Now let's go and see how we will get that 1D array filled. Okay, let's go on the board first. Just suppose we have to fill this second shell in the array. So what we need to do, first of all, we need some coordinates to traverse on this ring. What we need a starting point and we need an ending point. A starting and ending point means the minimum row and the minimum column from where we have to start, and the max row and the max column that we need to traverse on the ring. Okay, so how we will get it? So the minimum row, let's suppose the value of s is 2. So the value of minimum row is 1 1, because the index is 0 0. Here it will be 1 1. So we see a relation here that the value of minimum row and the minimum column is s minus 1, because the number of shell was 2, but this value, the starting minimum row and minimum column value is 1. The same goes for here also. If the ring was 1, the index was 0 0. It means it always follow this rule. The minimum row always be s minus 1 and the minimum column will be also s minus 1. So let's go and write this. Yeah. The minimum row, let me make it on the full screen. Okay, now it feels better. So minimum row will be s minus 1 and the minimum column will be s minus 1. We got these two starting point. Now we have to get the end point also. So here, if the value of s is 2, so the index was 1 1, 2 2, I think what it was 1 1, and this was I think 2 2. This is 3 3, and this will be 3 4. Okay, yes, this must be 3 4. So what will be the index for this one? For this, what we'll do, we will subtract s from the number of rows and the number of columns. Okay, so for that, what we need here, we max row as n minus s and max column as m minus s. Okay, let me explain you this. Just suppose here the value of n was 1 2 3 4 5. Okay, and the number of columns was 1 2 3 4 5 6. So the column was 6, which is represents m, and the n was 5. Okay, so it is 3 and 4. The value of s is 2. So if we need the column number, what we need subtract from m. So 6 minus 2 is equal to 4. That is the index that we need here for column. And for row, 5 minus 2, 5 minus s, that is the index that we need. So from this relation, the max row will be 3 and the max column will be 4. So we need m minus s for getting our max column and n minus s for getting our max row. Okay, we got it here. Now what we need? After this, we need to create 1D array that we will fill and return. Okay, so for creating 1D array, before that we need to calculate the size of the array. So what is the size of the array? Just suppose if we have to fill this shell, what is the size of the array? In the shell, we have 1 2 3 elements, so we have to subtract minimum row by maximum row, so we'll get the number of elements. But there is a clue I am going to give you. Just see what the maximum row is 4 and the minimum row is 1. Sorry, 3. The maximum row is 3 and the minimum row is 1. So 3 minus 1 is equals to 2. But we have 1 2 3 elements and it is giving us 2. So for balancing this, what we do, we will max row minus min row plus 1 to balance that one element. Okay, so we got the number of elements here on the left wall side. Okay, this is very simple as we have done in the spiral display part. So let's go here. What we will do, we'll define the size. So what was size? Elements of the left wall plus the elements of the bottom wall plus the elements of the right wall plus the elements of the top. Okay, just not this. What will happen if we do this? The corner elements will be repeated. So for avoiding this, we will simply subtract 4 from here because we have 4 corners. Okay, this is done. Now let's go and see how we will calculate the left wall. For calculating the left wall, as I told you, we have to subtract the minimum row by maximum row. So max row minus min row plus 1. This will be done. What for the bottom wall? Let's go and see what is the condition for bottom wall. Again, for the bottom wall also, we have to subtract the minimum column from max column, and again we have to add one to balance the elements. Okay, so here we are here, max column minus min columns. Okay, plus 1. Again on the right wall and the left wall is almost same, so we will use again the same formula, max row minus min row plus 1. Again, the top wall is same as the bottom wall, so we will again use the same formula, max column minus min column plus 1. Okay, so what we see here, we see that we have plus 1 4 times, 1 2 3 and 4 in this equation, and we have a negative 4 here, so that will simply nullify this. We will remove this part. Okay, so this is the formula that we have. Let me more neutralize it. Like the general formula for this should be, we have 2 max row, 1 and we have two max column here and here. And in subtraction, we have two min columns and two min rows and two min columns. Okay. Simply what we are going to do, we can write it as twice of max row minus min row plus max column minus min column. Okay, now let's remove this part. Okay, we have the size of the 1D array. Now just define the 1D array. 1D equals to, what we'll do, simply initially fill 0 size. Okay, this is done. Now we have the 1D array. Now what we are going to do, we are going to traverse on that ring and fill all the data in 1D array. Okay, so what we have to do, we have to traverse. First we will traverse on the left, then we will traverse on the bottom wall. After that we will traverse on the right wall. After that we will traverse on the top wall. It is same as we have done in the spiral display. Okay, let's go. So first of all, let's talk about the left wall. For left wall, let's go on the board first. Yeah, here we need two indexes, the minimum row and the minimum column to traverse. Okay, and from where to where we have to go up to the maximum row. Okay, so let's go. I will be minimum row, the j will be minimum column. Okay, so we will run a loop until our I is greater than or equals to max row. That is it. Okay, after that, inside this, what we have to do, we have to fill 1D array. Yes, we have to define one index also to traverse on our 1D array also. So initially it will be 0. So here 1D index will be equals to ARR of I and j. Okay, this is done. After that, what will happen, our index will be increased by 1 and the value of I will be increased by 1. Okay, these things are done. Now we have to get out of the loop, and now we have to take care of the bottom wall. Okay, so before moving forward for the bottom wall, what we have to do, we again need the indexes. Okay, so what was the indexes for here? For here, the minimum column was 1 and the max row, that is 3. Okay, so we'll give the max row, but for column we need to eliminate this element. Okay, because I don't want to repeat this element again in the array. So for that, we will use the j as the min column plus 1 to start the loop from this point. Okay, so let's go and write it down. I will be max row. Okay, and the j will be min column plus 1. Okay, this is done. Now again we are going to run the loop until when? Let's see. Here we have to run from this point to this point. It means we reach until the max column. Let's go. Write the condition here until our j is less than, oh, we missed here also, until our I is less than, not greater than, until our j is less than or equals to max column. Okay, so what we are going to do, again we will fill the 1D array I and j. Done. Again we will increase the index by 1 and the value of j by 1. Okay, this is done for the bottom wall. Now for the right wall, we are going to handle it. So when we start on the right wall, what was happening? The value of I was at the max row and the value of j was also at the max column. and we were reducing the rows every time until it became the min row. Okay, again we have to avoid the repetition of this element. For that, what we'll do, we'll initialize the I as max row minus 1. So the loop will start from this point. Let's go do it. I is equals to max row minus 1. Okay, and the j will be max column. Again we are going on the while loop until our I is greater than or equals to min row. This loop will run. Okay, and again we will fill our 1D array here. This is done. Again we have to increase the index by 1 and reduce the I by 1. This is done. Now what we have to do, we have to handle the top wall. For handling the top wall, we have to start from the minimum row and the minimum column, no, max column, and we have to go to the minimum column. So again I will be at min row and the j will be at max column minus 1 for avoiding the repetition of the element. Okay, so we are here again while loop until the j is greater than or equal to minimum of column. Okay, inside it again we have to do the same thing. We have to fill our 1D array equals to arr ij. This is done, and our index will be increased by 1 every time, and the value of j will be decreased by 1 every time. This part is done. Now after filling this, what we have to do, we have to simply return the our 1D array. This is done. The same thing will happen when we fill back this array. After rotating, when we are going to fill back that ring, again the same process is going to happen. Just what is going to happen, this 1D will be filled inside this array, not the 1D will be filled. Okay, let's go and copy this code here. We are here and we will paste this here. What we have to do, we just have to make some changes, fill back. Here also we need to make the same name, fill back. This is done. Inside this, what we have passed, we have passed array, the 1D array and the array, and we need to add one more 1D array. That's it, and the value of s that is given. Okay, array 1D array and s. Oh, I think I have make changes at the wrong place. We need to make changes here. Yes, 1D and the value of s. So here what we don't need the size. First of all, this is done. Now we don't need to declare this 1D array because we have 1D array this time when we came here to fill the ring. Okay, now we are here. This time what we have to do, we have to write here 1D index. We have to remove this part. We are filling back this time. Okay, so we are here again. We will move forward. We'll do the same thing here also. Equals to 1D idx. Okay, again we'll move forward, do the same thing, remove this part, and it is here now 1D idx. Okay, again same thing for the top wall, equals to 1D idx. Okay, this is done, and we don't have to return anything this time. Okay, so this is done. We have filled back. This is the all same code. Okay, Now let's go and handle this rotating part. This is pretty easy for us, we have already done it many times. Okay, let's go. We are here. We have to define one rotate function. Okay, rotate function. In this we have one 1D array and the value by which we have to rotate. Okay, it is here now. So let's go and see how we were rotating our 1D array previously. Okay, yeah. Just suppose this is the given array to us 1, 2, 3, 4, and 5. If we have to rotate it by 2, what we are going to do? Just suppose this was broken in two parts. This was the part 1 and this was the part 2. Okay, what is happening? There were 3 steps to do this. First of all, this first part was reversed completely. So it will become 3, 2, and 1. And this will be 4, 5. So what was happening in the second part? In the second part, this second part was reversed. So the array will be 3, 2, 1, 5, 4. And the last part was the complete array will be reversed. So what will happen? 4, 5, 1, 2, and 3. So what is this? This is the rotation of this by r equals to 2. So these are the 3 steps that we are going to do. Let's go and see. We are here. So before rotation, we have also to take care of 2 conditions. First, if the value of r exceeds the length of the array. Okay, first this thing, and the second thing, if the value of r is negative. Just suppose the value of r is -2, so what is going to happen? So this won't happen. What will happen? It will simply be these 2 words from the start will go at the last. So the answer will be 3, 4, 5, 1, and 2. So what it is actually the positive rotation by 3. Just suppose the positive rotation by 3 and the negative rotation by 2. These both are the same thing. We have discussed that previously. Okay. So just suppose how we are going to handle this. Let's go and write the code. So we are here. First of all, we need the size of the array. So size equals to length of 1D. Okay, we have the size. Now what do we have to do? We have to check if the size, if the value of r is not greater than the size. So r equals to r ampersand si. So what will happen? We will take the remainder, as we have discussed previously, that if the rotation is by 7 and the length is 5, so what it means, just suppose 1, 2, 3, 4, 5, we have to rotate this value by 7. So the first rotation, what it will do, it will bring it here. So 5, 1, 2, 3, 4. What will do the second rotation? Second rotation will make it 4, 5, 1, 2, 3. Okay, what will do the third rotation? Third rotation will bring 3 first. 3, 4, 5, 1, 2. Okay, and again what will do the fourth rotation? Fourth rotation will bring 2 at the front. 2, 3, 4, 5, and 1. What will do the fifth rotation? Fifth rotation will make it again 1, 2, 3, 4, 5. These and these, both the area are same. Okay, so again the same thing will start. After fifth, sixth will be this, and the seventh will be this. So the seventh rotation is the second rotation. So for that, what we'll do? We take the modulus of that. That's why we have taken a modulus here. Let me raise this. So this part is done. Now we have to take care if the given value of r is negative. If it is negative, so what we are going to do? Okay. What we are going to do? We are going to simply add the length of that, as we have discussed. As we have discussed here, the negative rotation of 2 is equals to the positive rotation of 3. from where it comes. Minus 2 plus the length of this string is 5 equals to 3. So it will be equals to the positive rotation of 3. Let's go and write it here. So the R will be equals to R plus SI. Okay, this is done. Now we are going to follow that 3 step to rotate this array. Okay, for that we have to call the reverse function. First of all, we have to rotate the first part from 0 to something that we don't know yet. We will figure it out later. Okay, so we have to pass our 1D array and the 0 is starting index and the some last index. We'll figure out what it is. Okay, after that we have to reverse the second part, which will again we will send it the 1D array and some starting point that we don't know. We will tell it later. And the last one, that is n minus 1. Okay, so we are here. After that we have to rotate the complete array. Reverse 1D comma from 0 to n minus 1. The complete array is rotated. Okay, this part is done. Now let's find out what will be here. Actually it won't be n here, it will be si minus 1 and si minus 1. Okay, this is done. So what will be the starting and ending point for this? Like for what will the ending point for part 1 and what will the starting point for part 2? So let's go and see on the board. Just suppose, let's erase it. We have 1, 2, 3, 4, 5, this given array, and we have to rotate it by 2. So first of all, the part will be from 0 to here. So what it will be? Just let me write the index 0, 1, 2, 3, 4. Okay, and the size is 5. Okay, so the index value from where to where it have to reverse, it is, oh, like this is the si minus r, the value by which we have to rotate, that is 2. So 5 minus 2 is equal to 3. So what it is giving? It is giving the this point. Okay, the starting point from where we have to reverse the second part. Okay, so let's go and write this in our code. The starting point for here will be si minus r. Okay, and just observe just one point at the back is the last point for the first partition. Okay, so we are here. What we will do? Si minus r minus 1. This is okay. We have write this code here, but we have to write the reverse function also. So let's go upside and write here or reverse function. This is also pretty easy for us. Okay, so what we are getting here, we are getting a 1D array and the left side of the index and the right side of the index. Okay, this is done. Now let's go and just reverse the array. So until li is less than right side of the index, this code will run. What will happen? There will be a temporary variable that will store the value of the left index. Okay, 1D of li is stored here. After that, what will happen? The value of right index will be stored in the left index. So 1D of ri. This is done. After that, what was happening? 1D of ri was updated. That will be equals to 10. After that, very simple thing, our li was increased by 1 and ri was decreased by 1. Ri minus equals to 1. Okay, this is happening inside the loop. When the loop will be completed, our array will be reversed. Okay, so this much part is done. So we have fill our 1D array first, then we have rotated that 1D array completely. After that, what we have done, we have filled back that array. Okay, so our all 3 parts are done. Let's go and run this code now. So we have some runtime error. Let's see. Let's go and see the error first. I'll try number 104. Okay, we have some typing mistake at this point. Okay, let's run this again. We have some error at line number. Okay, fill 1D array not defined. 1D array we have here. Okay, yes, I have changed the spelling. Yeah, so this is done. Now let's run it again and see. Again, we have some error. Fill 1D array. Here are index out of range. Okay, why it is out of range? Let me check. Min row to man column, we have managed that here. Okay, one thing we have to take care of when we were moving on that ring. Where is that ring? Let me go back. Yes, here. When we're reaching this point, what was happening? We were from here to this point. So we haven't managed this element. This corner element is getting repeated. That's why the index is out of bound. So for managing that, what we have to do, we simply have to run it till max column plus min column plus 1. Okay, so this loop will run till this point, till here. Okay, so this will save us, and then we have to make changes here also. Else what will happen, here also it will go out of bound. Okay, this is done, this is done. I think we are good to go. Now run it again. Let's see. Yeah, this is accepted. Now let's submit it for all the test cases. It is correct and met. I hope you have liked the video, and please subscribe the channel. Thank you so much for being here.